Hey guys, Buildzoid here, and today we're going to be doing more low-effort content. Now, I didn't think I'd be making a video about this when I first saw it on Reddit, because I took a look at this photo and I was like, that looks like a dead power stage. And the thing is, this is an RTX 5090, and RTX 5090s are high-end NVIDIA GPUs. And the thing about high-end NVIDIA GPUs is that they tend to have the power stages fail. Like, a lot. Remember all those RTX 3090s that were dying trying to play New World? Yeah, they were just blowing the power stages. Um, so I am not surprised to see a photo of a RTX 5090 with a blown power stage, because that just seems like something a 5090 would eventually do at some point. Though I will say I am surprised to see it on a Strix, or I mean an Astral, and I am surprised that it happened so soon. Um, but ultimately, without the card in hand or more of such failures, it's impossible to say if this was anything more than like a freak manufacturing defect. So, yeah, I didn't think I'd be making a video about this. So then why am I making a video about it? Well, I saw this article on video cards accusing an innocent capacitor of what I am 99% certain is a power stage explosion. And I'm guessing video cards got this capacitor accusation from this comment over here. This looks to be a blown capacitor. And this is just a thing that annoys me to no end. For some reason, people who don't repair GPUs or motherboards blame capacitors for like things that capacitors just don't do. Okay? Like, I'm assuming the reason why the capacitor is being accused of what is evidently a power stage explosion is because of this discoloration over here. But I am relatively certain that that discoloration is actually the internals, vaporized internals of a power stage. I guess vaporized and recondensed internals of a power stage. Um, yeah, that capacitor is not at fault here. The thing is, in my experience, like I've repaired a few GPUs. I've repaired so many GPUs I can't actually tell you how many I've repaired because I've lost track of them. I've repaired a couple motherboards. I have never repaired a GPU or a motherboard by replacing a solid polymer capacitor because these are basically indestructible, at least if you use them properly. There's like three ways you can get these to die. And they're basically like, so one, you could install them backwards. And that is a thing that ASUS did on a couple motherboards. They had a batch of motherboards where this style of polymer capacitor got installed backwards. And when you do that, what happens is these capacitors, instead of blocking DC current, they just conduct DC current. So they pull you basically end up with a lot of current flowing through the capacitor. The capacitor gets extremely hot. And in the case of those ASUS motherboards, there was like a MOSFET in series with the capacitor, and that MOSFET couldn't take the current, so that would usually burn up. But ultimately, that was caused by the backwards capacitor just pulling excessive amounts of current through a MOSFET that wasn't designed for it. Funnily enough, the capacitor itself didn't usually fail, as far as I know. And I've actually kind of done the same thing by accident myself. I once installed one of these, like this style of capacitor, backwards on the V-core rail of a Vega. I did not know that that capacitor was backwards until I tried to pull the card out of the system and burnt my hand on the backwards capacitor because it got just stupid hot. Yeah, but the card was fine. Like, it did not care about the backwards capacitor at all. Um, but anyway, um, yeah. So if you install them backwards, that'll cause them to pull excessive current, and that could eventually cause them to blow up, maybe. But this one's not backwards, because we can just about make out the polarity stripe. So unless the factory making these capacitors screwed up the polarity stripe, which if they did, like, the card would not work. You wouldn't have one capacitor that's backwards. They'd be all backwards. And other than that, we also have the SMT adapter plate over here, right, to make these capacitors surface mount. And that has the corners cut off to indicate the polarity on one side, and yeah, we can see that corner is also cut off. So this thing is definitely not backwards. Now, alternatively, you can also massively overvolt these. I once did that by installing a 2.5 volt capacitor on a 12 volt rail. I didn't read the label. I assumed it was 16 volts. It wasn't. And that produced a popping noise, and that was that. It really didn't actually produce a lot of drama. But yeah, also that 2.5 volt capacitor was backwards, so I like nailed it. It was backwards and like 2.5 volts on 12. So um, capacitor never stood a chance. Um, but this is a 16-volt capacitor. I mean, I don't know for sure that it's 16 volts. I can't actually see the label, but I'm 99% certain that it's a 16-volt capacitor because this card literally doesn't have any other flavor of 16-volt capacitor. Also, if it was like a 6.3 volt, right? Like these are all 16 volts. So I don't see how a like lower voltage capacitor would end up on here. Um, and if it was 6.3 volts or 2.5 volts, the card wouldn't turn on, right? This person was able to use the card because their PC randomly shut down while browsing websites. So evidently, that capacitor can't be massively underrated because if it was, they would have never been able to turn the system on. Um, so alternatively, you'd have to apply like 30 volts to it, which I don't know where you're going to get that. So, nah. And then finally, you can overheat these. Though my experience with doing that is usually using a heat gun. Because, I buy a lot of dead GPUs, and on those dead GPUs, when you try to heat gun off the dead power stage, well, those dead power stages are often very close to some polymer capacitors. And if you're not careful, you can accidentally cook the capacitor with the hot air while trying to desolder the dead power stage. So that's my experience with overheating these. And when you do that, what happens is if you overheat them a little, the casing swells up. Because the thing is, these are solid polymers, so they don't have any liquid in them. They're not designed to vent gases or anything. Um, and so if you really overheat these, they first puff up because the casing doesn't have any way to vent the internals if you start cooking them. Um, and if you keep cooking them, eventually the bottom of the capacitor blows out. And I've had, and like sometimes that'll just lift the capacitor up off the board a bit. But I've also seen them literally shoot off the board. So, um, yeah, which is why I now wear like safety glasses when working with hot air near capacitors because I really don't feel like getting 200-degree. Actually, it might be more than 200-degree by the time it blows off. But anyway, I don't feel like having, hot capacitors shoot into my eye. That doesn't sound very fun. Um, but anyway, so you can cook these, but you really need to cook them almost on purpose. Also, this doesn't look swelled up, and it doesn't look like it lifted off the board at all. So I'd hazard as a guess that this capacitor is completely fine, and so are all of the other capacitors on this card. Now, I have repaired some motherboard. Actually, I don't think I ever repaired a motherboard with a multi-layer ceramic, but I have repaired some GPUs with cracked multi-layer ceramic capacitors. So the problem with these is that these are very rigid, and PCBs are kind of bendy by comparison. And so what happens if you have like a multi-layer ceramic near, say, a screw hole, is that the PCB will bend as the screw gets tightened down, and the capacitor won't. So instead, it'll crack, and when it cracks, it internally short circuits. And then the next time you apply power to the capacitor, it lights up like a little light bulb well, okay, it depends on what power supply is hooked up to it, but my experience is usually they end up looking like a little orange LED. If you have them hooked up to something more substantial, they might like fizzle out pretty quickly. But they don't tend to cause like the catastrophic kind of damage that you get from power stages dying. Now, the thing is, though, these are really small, relatively speaking. Like, this is like usually the kind of capacitor that is susceptible to cracking due to PCB bent, like the PCB getting bent, is the larger types, like what we have over here. These are really small. Also, so there's no screw holes anywhere near this. Now, technically, we do have a thermal pad pushing down on the board. So that, if that thermal pad is too thick or too hard or both, it could bend the PCB and then like maybe crack this like these two over here or like these two, but like I doubt it. That seems incredibly unlikely. Like there are cards out there with extremely bent PCBs and you don't like I have like I think I repaired like 2 or 3 GPUs with cracked multilayer ceramic capacitors. Like, this is very rare in my experience. So, yeah. Also, none of them had like spectacular amounts of damage on there. Um, so yeah, there's like, to me, this is like 99% dead power stage. Um, so that's my judgment, and that's why I'm making this video, because it's just like, it just annoys me that capacitors, which generally don't fail and are borderline indestructible unless misused, get blamed for power stage failures, which are like pretty typical. Like, that's the thing that bugs me about this most, is like, based on how like people just always go like, oh, it's probably a capacitor problem, you'd think that like capacitor failures are like common or something, but they're not. Like, maybe on cheap electronics that use liquid electrolyte capacitors, capacitor failures are a common issue. But on GPUs and motherboards, all of the capacitors are some kind of solid polymer. They're basically indestructible. They don't die, other than the multilayer ceramics. But the multilayer ceramics are also solid and also don't die unless you like bend the board. So I don't get how this, like, how people just like always jump to blaming the capacitors, and it annoys me because it's like, it's not the freaking capacitors. It's like never the capacitors. So anyway, um, yeah, that's the main reason I'm making this video. Now, on to why this might have failed. Now, I don't think this is a case of like ASUS cheaping out on the components, because they're just using monolithic power systems MP86670 power stages. I mean, unless they're multi-sourcing the power stages for this card, which is possible, right? Like, we have, like, recently I did a video about like, hey, you can actually get 3080 Ti's with like both FDMF 3170s and also power stages from monolithic power systems. But I would assume I kind of doubt that ASUS would have been multi-sourcing power stages for like what I'm assuming is the first batch of 5090s. Um, so it's probably on these MP86 670 power stages. Um, and these have been used, like ASUS has used these on like a bunch of motherboards off the top of my head, and I think this is the first time I've ever heard of one of these dying. So I don't think this is like unless monolithic power systems had like a defective batch, I wouldn't blame the power stage for this. Right? Like, yeah, like maybe there was like one that was wonky or something, but I don't like, this is not some like bargain bucket, power stage. So I don't see a reason that that should fail in this application for no apparent reason, especially when just browsing websites. Um, now, alternatively, it could have been soldered badly to the board. So a concern with soldering power stages is that if there's too many voids in the solder, because the solder contracts as it cools, which basically means you get like pockets of nothingness inside solder joints under surface mount components with big like connection pads, which these have. These are what the pads look like. So yeah, that is a concern with soldering these, is that you could have like big gaps in the connection under the power stage, and that will make the power stage run incredibly hot. But we'd basically need, like, without having the card in hand, that's impossible to diagnose. So yeah, alternatively, there could be something wrong with the control circuitry of the power stage, so which could be like an actual design flaw of the card. So it could be like running wrong, and then like maybe there's like an issue with switching from idle to high power, or from, like there could be some kind of power management issue or something like that. But I doubt it. That seems like something that you would hope that they would, catch in the development process. Then again, NVIDIA has been apparently, like, the 50 series development process was kind of rushed, but I still don't think, like, GPUs have had idle power states for years. I can't imagine that like the 5090 has some bizarro power state management that would suddenly cause power stage failures. That just doesn't make sense to me. Um, so yeah. So my like default assumption in this case would be like, oh, maybe like bad soldering quality on one of the power stages. The main thing is, or well, main thing. Like, the owner of this card, they should just get this card replaced by ASUS, because this is not their fault. There's this is just like ASUS sent them a card with a dodgy power stage, either because of like soldering quality or maybe the power stage itself was dodgy. Like something was evidently wrong with it, and it shorted out and died. ASUS should replace the card. But the thing is, if this card had fuses, it wouldn't produce fire and it wouldn't produce smoke, right? Because this initial like shutdown is like, this is when I think the power stage, like the high side MOSFET died, which caused the system to shut down. And then with the still shorted high side MOSFET, the owner, power cycled the system, and that's what created all the fire and smoke, because they have a 1200 watt power supply. Because of course they do. They have a 5090. So, if we scroll through the comments, yeah, they have a ROG Thor 1200 watt PSU. If I'm not mistaken, this is like a relabeled Seasonic thing or something. And so off the top of my head, this is going to have an overcurrent protection of over 100 amps, right? So when a high side MOSFET shorts out, it literally just connects the input, 12 volts, to the output. Now, under normal circumstances, the way the power stage works is that this is a 5090, probably running 500 kilohertz. So the power stage is basically using that high side MOSFET to chop 12 volts into very short pulses of 12 volts into the inductor at like 500,000 times a second, right? So you get bursts of 12 volts getting applied to this side of the inductor 500,000 times a second. And through inductor magic, which is what we're going to call it for now, those short bursts or short pulses of 12 volts get turned into a much lower voltage on the output side of the inductor. Now, the problem is when your high side MOSFET shorts out, it no longer chops up the 12 volts, right? Instead of getting tiny little pulses of 12 volts, because this is, like say an 8% pulse, 500,000 times a second. So tiny little pulses. Instead of getting that, you just get 12 volts rammed straight into the inductor, which means the output voltage starts rising uncontrollably, which this is the MSVDD rail. There's not going to be a ton of capacitance relative to, say, V-core. There's a decent chance that the core on this GPU is dead now. I'm sure ASUS is going to be thrilled about having to pay NVIDIA for more GPU cores because they couldn't be bothered to put Actually, in defense of ASUS, you can't really put any fuses on a 5090 because the power distribution on this is just not designed with any kind of safety features in mind. It's like the power distribution on a 5090 and a 4090 as well, for that matter, is basically designed around the assumption that things don't go wrong. And when things do go wrong, you get fire and smoke spitting out of the card. Because you get like the entire output of the power supply getting dumped through this power stage, through that inductor, and through through part of the GPU core. So yeah, because basically like your power supply, like a 1200 watt power supply, right? When it sees that shorted out power stage, if that shorted out power stage is not low enough resistance to immediately trip the short circuit protection, it will just dump current into it, which is how you get all of the fire and smoke and also probably a dead GPU in this case. And the thing is, if there was a fuse in front of that power stage, that first failure would have hopefully taken the fuse out. And then when the owner goes to turn the card on again, you don't get any fire because you can't apply 12 volts to a dead power stage a second time. Yeah. The main point of this video was, though, please don't blame capacitors for power stage failures. Capacitors are really, really reliable. Power stages, on the other hand, even high-end ones, aren't. Like, I have a Strix 2080 Ti with a Texas Instruments, 80 amp power stage, and I had to replace it because one of them blew up. I don't know why it blew up, but it did. I have Like I have a whole bunch of 980 Ti's that had dead power stages. I just like I repaired two different 3090s that had dead power stages. Admittedly, those were like cheap power stages, not high-end ones, but like power stages failing is a thing that happens a lot. So like maybe we should design the uber expensive GPUs to resist power stage failures a bit better than just hoping that the power stages don't die, because they do die a lot. um, anyway, this is almost certainly not a capacitor failure. Um, and that's it for the video. So hopefully you found this somewhat interesting, if not particularly useful. And that's it. So thanks for watching. And oh, if you'd like to support the channel, there are links in the description. You could check those out. It would be very much appreciated. And am I forgetting anything? I don't think so. So I guess I'll just hit the stop button now. Thanks for watching and goodbye.